B2 acceleration. This is another quantity that arises naturally in kinematics, and this deals with the change in the motion. Now, back in 2009, I published a paper on kinematic measurements from YouTube videos in the physics teacher. That was the first publication using YouTube in some way to teach physics. And then since then, of course, there's been a lot of publications and examples. The example that I did, one of them that helped me get inspired, was one that involved a BMW motorcycle, like this one here. And in the YouTube video, it accelerated and showed the speedometer. Now, the particular video I used, some believe that the author used a little bit of trickery and the data may not be 100% authentic. However, if you take this data as given, this is reasonable data. This could be very, fine, because it's within the range of speeds for the bike. And we will go ahead and take this as a given, which I did get from the video by watching each second, like stop the video and write down in kilometers per hour. To get an idea of the concept of acceleration, let's make a little chart where we have the time in seconds and the speed in meters per second, and say a time t equals 0, the speed is 0. So this could be represented by t and the speed by the letter v. Then after 1 second, say we're going 2 meters per second. And then after 2 seconds, we're going 4 meters per second. And after 3 seconds, 6 meters per second, and so on. 4 seconds, 8 meters per second, 5 seconds, 10 meters per second. So here, the change in velocity at each step, if we look at this, it's gaining 2. It's a plus 2. A plus 2, plus 2, plus 2. And we call that delta V. This is the Greek letter delta, uppercase delta. Lowercase delta is this one. Delta V is the change in velocity, and you can think of it as a final velocity, minus an initial, or the second velocity minus the first one. So this is the initial, this is the final, and then this becomes the initial, and then that's the final for the next consideration. So in that case, we're seeing that the acceleration, the concept of acceleration, is we're gaining 2 meters per second. Now, whenever we do per, we do a denominator for the location. So this is 2 meters per second, and don't mind the 2 seconds there. We're going to write that as 2 meters per second squared, and that's the unit for acceleration. So this 2 meters per second, you can think of that as a delta V, is your 2 meters per second, and since the acceleration is constant, every second it's going to be the same. And the delta T is the 1 second, and by taking delta V divided by delta T, that's